Hello, welcome to this third video. This is 5-6, and we are talking the fundamental theorem of calculus. This topic will be useful going forward in calculus. It will be useful going forward in Calc 2. It will be useful going forward in Calc 3. The fundamental theorem of calculus, we use this a lot when integrating. So let's go ahead, look at some examples, and kind of recap the fundamental theorem of calculus. So here it says, if f prime is a continuous function on a to b, disclaimer, doesn't work if it's not continuous on the interval, then the integral from a to b of f prime of x dx is equal to f of x evaluated from a to b. Okay, so f of b minus f of a. And again, like I said, this is very, very important. It's very, very fundamental. Okay, so let's go ahead and look at some examples. So it says evaluate using the fundamental theorem of calculus without using a calculator. And later on, these problems will just say evaluate. So we're asked here, what is the integral from 0 to 4 of 2 times square root of y plus 1 dy? Okay, so using the fundamental theorem of calculus, it says if I integrate this, okay, I can evaluate from 0 to 4. So I'll go ahead and I'm going to integrate this. I need to just kind of adjust this before it is ready to integrate. So that's y to the power of 1/2 plus 1 dy, and we're going to go ahead and integrate. So I have 2y to the power of 3/2 over 3/2 plus y. Okay, and notice I don't have a plus c. There's no plus c's in the fundamental theorem of calculus. That's an indefinite integral. Here it's definite. I want a numerical value. Okay, and I'm going to evaluate, so that's what that bar means, from 0 to 4. So let me just kind of clean this up. I'm going to rewrite this. This is 4/3 y to the 3/2 power plus y evaluated from 0 to 4. Okay, so all I did right was multiply by the reciprocal. Okay, so here's what we're going to do. I'm going to go ahead and I'm going to rewrite these two values in different colors because I want you to see this. I'll write this one in red and then this one in green. And all I'm going to do, so after you've integrated, is just evaluate in these values. So we have 4/3. Okay, now I'm going to plug in 4 for y to the power of 3/2 plus y, which is 4. Okay, and I'm going to subtract, okay, all of this. I'm going to subtract f of 0. So I have 4/3 0 to the power of 3/2 plus 0. Okay, so that's how it works. Make sure you include the parentheses. You need to subtract that whole thing. So we'll go ahead and simplify here. Square root of 4 is 2. 2 cubed is 8. 8 times 4 gives us 32 over 3 plus 12 over 3 minus, here, this is just a big fat 0, right? Okay, so 0. Okay. Ooh. Computer's gonna die. Okay, big fat 0, and we get 44 over 3. Okay, there it is. All right, let's go ahead and look at another example. All right, how to move and plug in my computer. Okay, so here is example 11, and again, we want to evaluate this integral from 0 to 1 of 4t plus 1 to the 5th dt. So in order to go ahead and integrate this, notice I have some chain rule going on here, so I need to do reverse chain rule, and I need to get my unhook factor. Now, when I do this unhook factor, notice the derivative of the inside is 4. So I have to go ahead and introduce a 4, okay, and in order to balance this, I have to multiply by a 1/4, okay, so there it is. Okay, so I'm going to go ahead and integrate this now. So we have 1/4 of 4t plus 1 to the power of 6 divided by 6. Okay, and we want to evaluate from 0 to 1. So this is 1/24 times 4t plus 1 raised to the power of 6. Again, evaluated from 0 to 1. So we're going to go ahead and evaluate. So I'll plug in 1/24 times 4 times 1 plus 1, or again raised to the power of 6, okay, minus 1/24 4 times 0 plus 1 to the power of 6. Okay, and so what we get here is we get 1/24 times 5 to the power of 6 minus 1/24. Well, this becomes what? 1 to the power of 6, which is just 1. So minus 1/24. Okay, and there's your numerical answer. Simple enough. Fundamental theorem of calculus. Okay. Now we're going to go ahead and look at number 12. And number 12 is kind of gnarly. That's because hopefully you see the square root and you're thinking, oh no, here comes U substitution, and that is 100% correct. We're going to have to do some U substitution here. So I'll get this ready to go, and what I'm going to say is let U be equal to 2x plus 1, okay, which means that U minus 1 is equal to 2x, which means that x is equal to 1/2 U minus 1/2. Okay, and that dx is equal to 1/2 du. Okay, so all I did was just kind of identify using a U substitution what those values are going to be, what dx is, what u is, what x is, and something that we also have to do is adjust our bounds. So notice this is x equals 1, okay, and x equals 5. So I need to know, okay, if x is equal to 1, what is u, and if x is equal to 5, what is u? So notice over here, I'm going to write u is equal to, okay, so I'm going to plug in just 1 here. So 2 times 1 is 2 plus 1. That gives us u, oh, I have an error. I know you've been like, Schwarberg, I've been trying to tell you. It's minus 1. So that makes this plus 1, plus 1/2. Okay, so then u is going to be 1. If x is equal to 5, then we have 2 times 5, that's 10. Take away 1, that gives us 9. U is equal to 9. Okay, so I found my new bounds, and that's very, very important, right? So I'm going to write here, change bounds, or change your endpoints, okay? So, or change your interval. So in relation to u, I'm going to integrate with respect to u, so that's what we're going to have to do. Okay, so let's go ahead and let's rewrite this integral. So I have the integral from 1 to 9, okay, x, so I need to replace x with 1/2 u, 1/2 u plus 1/2, okay, and I'm going to multiply times, so notice I have the square root of 2x minus 1, so that is u, right? This would be the square root right here, square root of u, and it's in the denominator, so I'm going to make it to the negative 1/2 power. Okay, times, and then I have dx. So dx is again 1/2 du. Okay. All right. So now what we want to go ahead and do is we want to do some multiplication and simplification. So I have the integral from 1 to 9, and I'm going to multiply these values in. So 1/2, this gives us 1/4. u to the power of 1 combined with u to the negative 1/2 is going to give us u to the power of 1/2 plus 1/4, that would be u to the power of negative 1/2. Okay, and then all of this is being integrated with respect to u. Okay, so now we are ready to integrate, and we'll go ahead and do such that. Do that, such. We're going to do it, okay? So we get 1/4 u to the power of 3/2. Okay, and all this is divided by 3/2 plus 1/4 u to the power of 1/2 divided by 1/2. Okay, and we want to evaluate from 9 to 1. So I'm going to simplify this. I'm going to kind of clean it up. Okay, and this would give us 1/6 u to the 3/2 plus 2/4, that's 1/2. 1/2 u to the power of 1/2. Okay, and again, it's evaluated from 1 to 9. Okay, so now I'm going to go ahead and I'm going to just plug it in. So we get down here, we get 1/6 times 9 to the power of 3/2 plus 1/2 of 9 to the power of 1/2. Okay, and I'm going to minus, or I'm going to subtract all of this. So 1/6 times 1 to the power of 3/2 plus 1/2 to the power of 1 to the power of 1/2. Whew! Okay, so let's go ahead and kind of tackle this one by one, pretty simplistically. So the square root of 9 is 3. 3 cubed would be 27. So we have 27/6 plus, it looks like 3/2. Okay, minus, I have in here 1/6. Okay, plus, it looks like 1 to the power of 1/2 is just 1. Okay, so plus 1/2. And there would be your answer. This is a numerical form. Okay, so that would be good enough. And if you are looking for the final answer, it would be 16/3. Okay, but this is a numerical value here. And that would give you your answer. Okay? All right, so that is the fundamental theorem of calculus. Whew! All right, it's a big one, but very, very important, and very, very useful. Okay, catch you next time. Peace.